In this presentation, we have to talk about the fundamentals of relativity theory. Frame of reference is an important concept existing in the theory of relativity to describe the motion of a particle. A system of coordinate axes used to specify the particles in 2 or 3 dimensional space is called a frame of reference. See, here is a 3-dimensional frame. X, Y and Z are the 3 coordinates used to describe a particle's motion. A frame of reference can be classified majorly into 2 categories. One is inertial frame and the other is non-inertial frame. A frame which is at rest or moving with the constant velocity is called inertial frame. That is, the unaccelerated frames are called inertial frames. A frame which is moving with different velocities at different places is called non-inertial frame. Therefore, the accelerated frames are called non-inertial frames. We may classify the theory of relativity into 2 categories majorly. One is the general theory and the other is special theory of relativity. The general theory deals with both inertial and non-inertial frames, whereas the special theory talks only about the inertial frames. In the case of special theory, 2 postulates are existing. The first postulate is the laws of physics are the same in all inertial frames. The postulate 2 is the velocity of light in free space is constant. It is independent of the relative motion of the source and observer. To understand more about the first postulate, read out this paragraph. The first postulate reveals that a universal frame of reference is not in existence. If the laws of physics are different for observers in a relatively uniform motion concerning one another, which means that one frame is at rest and another one frame is moving with the constant velocity, these differences would enable us to determine which objects are stationary in space and which objects are moving. The meaning of this paragraph is, if the laws of physics are not same for different observers, we may easily point out which object is at rest, which object is in motion in the space. But we won't say like that, which means that the laws of physics are same in all the frames, whether the frame may be at rest or moving with constant velocity. Then in the case of postulate 2, the velocity of light in free space is always a constant. In the case of Michelson and Morley experiment, we are using the terms c plus v and c minus v. If they use c plus v and c minus v, they have had negative results. The experiment has given negative result. Therefore, anything added to light will provide velocity of light. So this is also velocity of light. So the velocity of light is the maximum one. We won't add anything to velocity of light. Even if you add anything, we can get finally the velocity of light. So that velocity of light is always constant. This is postulate 2.